Okay, so this is problem 10.61 where you're given a solid piece of carbon dioxide that has a mass of 5.50 grams, and it's going to be placed in a 10-liter vessel that already has air at 705 torr and 24 degrees Celsius. After the carbon dioxide is totally vaporized, what is the partial pressure of carbon dioxide and the total pressure in the container at that 24 degrees? So the plan here, like I've got, is you're going to have to change the grams carbon dioxide to moles carbon dioxide. Alright, and then remember that the pressure, you have to find the pressure of CO2 first, and that the pressure of CO2 plus the pressure of the air is going to give us our total pressure. Alright, so if we start 5.50 grams CO2, alright, divided by 44 grams per mole of CO2, so the grams cancel, that's going to give me 0.125 moles carbon dioxide. Okay, and then using the ideal gas law, in this case I want to get the partial pressure of CO2. Well, I just need to solve this equation for pressure, so I'll take and divide both sides by the volume, so that if I've got the temperature, if I use a 10-liter volume, I use N, this is the moles of CO2 right there, multiplied by R, and then all that divided by V, that'll give me the partial pressure of CO2. Then I just have to add back the pressure from the air, and that'll give me the total pressure. Alright, so solving for pressure with the ideal gas law, I've got moles of carbon dioxide is equal to 0.125 moles. So if I multiply 0.125 times 0.0821 times 297 divided by 10, I get 0.305 atmospheres. Now the pressure from the air, they said, was 705 torr. So if I divide that by 760, I get 0.928 atmospheres. Okay, and then if I add those up, plus 0.305, I get 1.23 atmospheres. So the pressure from the carbon dioxide, 0.305, the total pressure then would be, if I add those up, 1.23 atmospheres.